Hello everyone, myself Dr. Manoj Kumar, working as an assistant professor in Department of EC at MLR Institute of Technology, Hyderabad. Today I am here to deliver a lecture talk on dual beam and dual trace CRO. This is overview of my presentation. First of all, I'd like to discuss basic concepts of dual beam and dual trace CRO. Thereafter, I'll be taking the classifications, construction, working principle, and finally some of application of dual beam and dual trace CRO. So let us understand. Before going ahead, I would like to discuss about CRO. What is CRO? CRO is nothing but an electronic test instrument. It is an electronic test instrument device which is used to display and analyze the waveform of electronic signal. What are the basic function of a CRO? Basic function is that it converts the electric signal into some waveform that can be analyzed and visualized. Different types of CRO. Normally, a CRO has single beam CRO. Single beam CRO means it has single electron beam and at a time it can display one waveform. But as the technology advances, we have dual beam CRO and dual trace CRO along with digital oscilloscope. Already I have discussed about the normal CRO or single beam CRO. In this lecture, we will try to discuss about dual beam and dual trace CRO, which are the types of CRO only. But what is the meaning of dual beam and dual trace CRO and what is its purpose, we will discuss in this lecture talk. As the name is suggesting, dual beam, it will have the 2 electron gun and it will display the dual beam, 2 electron gun, dual trace, single electron gun. Two electron gun, two waveform at a time. It also dual trace has single electron gun, but it can have the ability to display 2 waveform at a time. So, dual beam or dual trace. Dual means 2. It will display 2 waveform at a time. So, in dual beam, using 2 electron gun, it will display the 2 waveform at a time. And in dual trace, in spite of having a single electron gun, it has ability to display 2 waveform. Only the displaying mechanism is different in both cases. So, dual beam CRO 2 waveform at a time, dual trace also 2 waveform at a time, but the displaying mechanism is somewhat different. Let us understand in the upcoming slides. Dual beam CRO. As the name is suggesting, dual beam. Dual beam CRO uses 2 electron beams to display 2 different signals simultaneously. So, 2 electron gun are used to generate 2 separate beams. Each beam is focused on different part of the CRT. What are the features of the dual beam CRO? It has simultaneous viewing of 2 signals, adjustable time-based voltage, and what is the application? Used in the scenario where comparing of 2 waveform is required. So, dual beam used to display 2 waveform, and what is the application? It can be used to compare the 2 signal or 2 waveform. Dual trace. Dual trace can also display 2 signals. using one electron gun. This is the important part or important features of dual trace. Dual trace means two waveform but using only one electron gun, and it can display the two traces or two waveform alternately. Working principle: it uses a single electron gun and the signals are displayed alternately. In dual beam, the signals were at the simultaneously displayed, but here with the some time interval of millisecond, it is displayed alternately, either in a time multiplexed manner through a switching circuit. So the dual trace will also display two waveform alternately, not simultaneously, but alternately with the some time interval of millisecond. And this millisecond time interval is not sensed by our eyes. That's why the signal appears to be that it is displayed at a time using dual trace CRO. But the mechanism of displaying the waveform in dual trace CRO is quite different. It will display two waveform but alternately, and the alternate time interval would be in millisecond, and it will try to create a illusion type of thing to the human being. As we know that human beings are not habituated to capture the millisecond duration time interval. So if the signal is switching in the millisecond, it will appears to us that it is at the same time. So this is the displaying mechanism of dual trace CRO. So what is the application of dual trace? It is used in the scenario where the simultaneous measurement of two signals is needed, but we want less complexity than dual beam. The hardware complexity in dual trace is very less as compared to dual beam. So in terms of hardware complexity, dual trace CRO has less hardware complexity. That's why, depending on the purpose, we can use dual beam and dual trace. Dual trace CRO has less hardware complexity, so it is obviously cheaper as compared to dual beam, but it can be less accurate. Why? Because the two waveform are not being displayed simultaneously, it is displayed alternately. So for the precise measurement, we can go for the dual beam. For non-precise and for laboratory purpose, we can go to dual trace CRO, where the accuracy doesn't matter too much and hardware complexity is also less in the dual trace, and it is economical as compared to dual beam. Basic components of dual beam. We'll try to see what are the basic component of dual beam CRO. Dual beam CRO has electron guns. It has two separate electron guns. Each electron gun is used to generate an individual electron beam. Each gun is used to generate an individual electron beam that strikes the phosphorescent screen to form a trace. Trace means a visualized point, a visualization of the waveform. Trace. The electron gun are placed at the opposite end of the CRT. The meaning of this line is that dual beam CRO has two electron guns, and both electron gun will eject the electron separately. Then we have CRT. In dual beam, inside the CRT, we will find the two electron gun placed side by side. CRT has a phosphorescent screen where the electron beam are directed to create a visible waveform. CRT is divided into two separate sections, allowing each beam to be directed independently to different part of the screen. So both beam will be deflected independently. There is no correlation between both beams, both electron guns. Then we have deflection system. As I told, to visualize the waveform, we have to move the electron beam in horizontal direction as well as vertical direction, then only we can visualize any waveform. So here we can see that two waveform are there, channel A, channel B are there, and we have a delay line as seen in the normal CRO also, and we have two separate vertical amplifier. Channel A will be deflected by this vertical amplifier independently, and channel B will be deflected by this vertical amplifier independently. After deflection, it will be given to vertical plates. So in dual beam, we will find two pairs of vertical plates, and we have two sweep generator which will provide a horizontal deflection. So in dual beam, the concept is clear that we will have two electron gun 1 and electron gun 2. Electron gun 1 will be used to display the channel A waveform. Electron gun 2 will be displayed to channel 2 waveform independently. There will be no correlation or no switching between E1 and E2. Both will be deflected independently by the vertical amplifier and then to the vertical plates. And similarly, we have two different sweep generator. So this sweep generator will control the channel A, and this sweep generator will control the channel B horizontal movement. So in dual beam, here we can see that hardware complexity is more because of applying two electron gun and two sweep generator independently. But we will have the precise waveform on the screen, and two waveform we can see at the same time without any delay on the screen. What is the construction of dual trace CRO? Here also we can see that there are two channels, means two waveform, but only we have one vertical amplifier. See here how the hardware complexity is reducing. In dual beam, we are having the two vertical amplifier. Here no need of two vertical, only one vertical amplifier is enough to deflect both beam. So hardware complexity is getting reduced in the dual trace, and also we can see that we have only one time based generator. So by seeing the hardware complexity, it is less complex than the dual beam construction. The thing is that suppose at time t1, this channel is connected to this vertical amplifier and the channel A waveform is displayed here for the some moment of time. Then after some time, this switch is connected to channel B and the channel B signal is propagated through this switch and then to vertical amplifier and then to vertical plate. So in this way, what is happening? Channel A and channel B, both waveform are being displayed. Both waveform are being displayed on the screen using a single vertical amplifier and with the help of electronic switch. At one moment of time, this channel 1 will be displayed, another moment of time channel 2 will be displayed. So in this way, based on the time division multiplexing or time division switching, we can display two waveform on the same screen, but alternately we are displaying alternately, not simultaneously. In dual beam, we are displaying the waveform simultaneously, but here alternately with the certain time interval less than millisecond. As we know that we can't trace the millisecond interval, so it will, for human being, it will appear that both waveform are displaying simultaneously, but in actual it is alternately. So this is the quite common difference between dual beam and dual trace. So it will give the waveform alternately, that will give the same time. Dual beam will give the waveform at the both waveform at the same time. Already I told, dual trace will work in two mode, alternate mode and chopped mode. In alternate mode, we can see that in one sweep time, channel A waveform is displayed. In another sweep time, channel B waveform is displayed. Then again in third time, we have channel A waveform. Again in fourth time, we have channel B waveform. So in this way, alternately, for some time channel A, then channel B, channel A, channel B. In this way, both waveform are being displayed on the screen at the same time, or you can say that in alternate manner based on the time division. This is called alternate mode. So based on the one sweep cycle, channel A is displayed, and in another sweep cycle, channel B is displayed. So these are nothing but the sweep time. But in the chopped mode, we can see that in a single sweep time, channel A and channel B both will be displayed based on some microsecond or millisecond multiplexing. So in alternate mode, in one sweep time, channel A, in another sweep time, channel B, then channel A, channel B. But here, in one sweep time only, we have divided or multiplexed the channel A and channel B waveform to be displayed on the screen. So this is called chop mode. So here we can see that electronic switch will make a several transition from one channel to another during one sweep. But in last slide we have seen that one sweep was totally reserved for channel A, and another sweep was reserved for channel B, then third sweep channel A. But here what is happening, in one sweep they have fragmented the sweep, and for one fragment channel A, then another fragment of time channel B, channel A, channel B, like that. So in one sweep they have chopped out the time, and based on the chopped time the waveform are being displayed on the screen alternately, A and B, A, B, like that. So this is chopped mode, that was the alternate mode. Conclusion. So in summary, we can say that dual trace CRO is simpler oscilloscope that uses a single electron gun to alternate between two input signal. It is cost effective, sufficient for many applications requiring the comparison of two waveforms. Application. It is very ideal for the application where the analysis of two signal is needed. Whenever we want to compare two signals precisely, accurately, use dual beam. For laboratory purpose, if you want to compare two signal, use dual trace, because the hardware complexity is less in dual trace. So for laboratory and laboratory purpose, we can use dual trace, but for R&D purpose, try to use dual beam CRO for the accurate measurement of two signals. So this was all about dual beam and dual trace CRO. Thank you.